Ross, you got the boot off.
Boot is off, back to normal.
Apparently, and you've been busy. What have you done?
Yeah, so we're getting a lot of questions about HVAC systems that are too loud, right? HVAC acoustics is a big deal, and if you're a loud system, it's a problem,
People
right?
hear the rattle, they hear the whistling, it drives them crazy.
That's right. So when you think about an HVAC system, this is the demo, this is the prop that where air comes through the return, it goes through the air handler. So this black thing is the fan. That would be like your air handler, your furnace in your system. Then it comes out through the supply, and it goes through the supply truck, and it goes out to supply registers there.
Okay. And what is it that we're actually hearing that's bothering us? I'm sure there's a scientific answer.
Yeah, so noise is really vibrations, right? So when you have things that vibrate, that transfers into sound waves, and that sound waves make their way to your human ear, and that's what you hear.
Okay,
right.
Vibrations obviously caused by a moving fan.
The primary candidate in residential systems is the air handler, the furnace fan, right? So that blower wheel that spins, and the faster it spins, the more noise it generates.
Okay.
The other one is air velocity. Air that's moving too fast, it creates that whistling, it gets that air moving too fast where you're gonna hear it through the duct or through the register when it comes out.
So that's creating vibrations as well?
They both. Yep.
Does your prop work?
It does.
Of course it does.
Of course.
Dad would be proud. Apparently prop making is genetic.
So it's a great way to demonstrate. Here's the return register. Now I can take a sound pressure level, right? So I can measure the sound coming out of the system, and this is in decibels.
Yeah.
And I've actually called it dBA, it's the A-weighted scale. If I put it up to the unit, I'm about 80 dBA. All right.
And that's because you're close to the motor, and that's actually what it's picking up, the sound of that motor.
The sound's traveling by line of sight right out through that return register, and it's really noisy, and that's why a lot of systems are ducted. But guess what? If I added return ducting to the system, like flex duct or a couple bends, I can dramatically reduce the sound level. And so I could drop it from 80 down to 70, and it might not sound like much going from 80 to 70 on the dBA scale, but that represents twice the loudest. So if I'll cut it in half by going from 80 to 70.
Wow, that is a big difference.
Huge.
And so if I understand it correctly, you're solving the problem by simply just moving the source of the noise, which in this case is the register, further away from the motor. But is it also the bend that is helping you in the distance?
Yeah, so it's moving it further away proximity. It's also the line of sight. The sound travels by line of sight. So now by adding that bend in the flex duct, it has more chance to absorb that sound.
Clever, okay. But that's fan motor. Sometimes these things are in the attic, the basement, really far away.
Yep.
And they're still noisy systems.
That's
and
right.
that's because the air is cranking, right? I mean,
Yeah,
the air is actually coming out of these pretty fast.
So when it comes to air velocity, right? So if I measure the air velocity coming out of these, I mean, I could be at 75 decibels, right? That's really, really loud. But now a homeowner saying, oh, I got too much air blowing out, they crank it down, now it starts whistling.
Because I've choked it down, I've increased the velocity here.
And now I'm up to 76, 77 decibels.
Have I also increased the velocity elsewhere?
That's right, because it's interrelational. If I adjust this one, I'm gonna get more air coming out of this one, which means more noise coming out of here, right? So we wanna make sure we're cognizant of the air velocity coming out of these registers.
What are my solutions?
Simplest thing you can do is adjust the air handler speed. Sometimes the air handler is just tuned up and jacked up way too much, and so you're moving too much air, too much velocity through that system, and you got to find that balancing act between reducing that for sound, but also not reducing it too much so you have a performance issue.
Okay, and are you suggesting that this is not the right place to sort of choke these down, you know, because it increases the velocity and noise here?
Yeah, so choking it there creates that turbulence and that extra air velocity. If you can adjust it here, that balancing damper back in the wall or back by the main branch, that allows you to reduce the airflow there and not at the register. So any turbulence happens further upstream.
So that's further away from where our ears are.
That's right.
Very
Yep.
nice.
And then now what I can do is I can make sure that the flex duct is actually elongated. You don't want the flex duct to be compressed, right? When it's compressed, it doesn't do much for you. Now it's allowing you to muffle that sound and we're giving you that proximity.
So same idea as you showed us over there, and that's going to reduce the dB coming out of this register just by pulling it away and turning it?
That's right.
Wow.
So
But Ross,
65, 66.
when you say a balancing damper inside the system here behind the wall, this is now behind the wall, that's to me got to be done at a good design, or you get lucky with a retrofit.
That's right.
If I can't do those, is there anything I can do in the room?
Yeah, so first thing, when I walk into a room, a lot of times I'll see wooden registers or really restrictive registers. And if I compare this 4x10 register, metallic versus wood, this is 50% restrictive, this is 70% open.
Both 4x10.
Both 4x10.
More restrictive.
Way more restrictive, more chance of
noise.
whistling, more noise, more velocity, right?
Okay.
4x10, so I could literally be as simple as changing out this register for that register, it's the same boot.
Right. Very nice.
And I could also go slightly larger. I could go to a 6x10. Instead of a 4x10, I go slightly larger.
Bigger register.
I do have to change the boot, but it's the same duct size.
So 6 inches here to a small boot to a small register, same as 6 inches to a big boot, big register.
That's right.
Less noise.
That's right.
Rock on. Well, this drives a lot of people crazy, so this is going to be a solution they're going to want to hear.
Yeah.
Thank you, Ross.
All right.
Thanks for watching. This Old House has got a video for just about every home improvement project, so be sure to check out the others. And if you like what you see, click on the subscribe button to make sure that you get our newest videos right in your feed.